chessboard. Okay, let's not do this in chessboard. I didn't even make a directory already yet. Let's just go to C++. I think. Make dir Minesweeper. CD Minesweeper. Oh boy, yeah, it's a usual thing. Actually, yeah, maybe I should do it in projects. No, don't want to make. Don't want to put that much time into it. I'm not going to call that project. But then again, am I going to do this without Git or not? If I'm not going to, if I'm going to do it without Git, then I can't use my utilities and stuff, which is always sucks. Let me think. No, I won't use Git. Let's just do it, you know, a 1 or 2 day project. So the idea is as follows. I'm going to write a solver. And that means, of course, that we have solver.cpp. See exact. And let's include vector.h. I'm exclusively working with vectors, I think. But we can do using board is vector. Now they have column, comma, row, or row, comma, column. I never know that. I think I used to use column, comma, row somewhere. I'll let you do that. Cols, comma, rows. Bits. I don't know why am I using capitals there. Because these, of course, are just integers. Const expression, integer. Cols, right? Cols. How many columns? Well, 6. Keep it small. Rows. But I'm going to code it such that if I change this to something larger, then it will still work, right? And then we have a const expression int bits. So bits per square. So in a vector. So we have 4 bits, I think. Maybe it's enough. Number of columns of the minefield. So 1 word or 2 words? Minefield. Number of rows of the minefield. Let's make them different so I can see what's up there. The reason I chose 6 is because I want to have something around it, and then if I do that, it's 8 by 8. And that is 64 in total, times 4. Yeah, okay. I'll keep it at 6 at the moment. Or maybe not. Yeah, no, let's make them different. I'm just going to make it even smaller. Let's say 5 columns. Okay, this is the number of bits per vector element. which corresponds to 1 square in the minefield. Now, this is not true. The board, of course, exists of multiple such vectors. So I have to use something else. It's a variable, maybe. I'd still like to call it a vector. Gonna call it this is one vector, and then I'll probably need to use a different name here. It's my template vector. Vector template. Calls, comma rows, comma bits. And then we have a class board. That's the whole board with the complete state. I don't understand that. Who needs private and stuff? Just everything public. Oh, that's very lazy. Nah, it's not just not. Let's not do that. Private. It's by default private, but okay. Also have public stuff. I think that my board exists of several vectors, namely known empty, known mines. It's more like a solver state. We also have a solution, I think. Well, the board, the actual minefields would be like the mines, just the mines. We make that const. So we just, you know, the actual hidden mines. I'm thinking about this is more like part of the solver. Maybe I should make this not const. And then make these two part of another vector. Whoops, another class, I mean. Let's call this class solver. Now the solver is derived from board. Is that a good one? So we have this board here, and then we can take and derive a solver from it. Nah, not really correct. Private. Right. Let's make a default constructor that does nothing at the moment. That's nonsense. I need a pause a board tutorial. Let's shall I pause it as a wait a minute. I'll make it. Why not the is this yeah. This thing is const. I mean, if I add const here, I might as well make it a reference. I mean, a reference is a pointer const, so this thing and that's the same as a reference. But I did pick pointer for a reason. It feels better, so maybe it's not a reference then. Let's just pass a pointer here as well. I'm not happy with the word board. Well, no, board. It's more like the problem. We should call it problem. Minefield. Field. Stick with the board for now, I guess. Okay, can at least initialize that then. Then we have default constructors for these two. Now note that this is a Boolean vector. I think that maybe I should make a difference between a vector that actually uses the bits and a vector that only stores booleans, because I'm probably going to have quite some Boolean vectors, like this is on or off, this is a mine or there's no mine. This one either. We know that's empty or it's not. We know that's a mine or that it's not. It's all Boolean vectors so far. Could call it the grid instead of a board. Yeah. Ah, okay. Why not? So then a grid is a known, even the class then. All right. Board. We'll choose here board just to give more information than we already have. Well, that's a default constructor. I guess the default constructor could just generate the whole minefield, and then it's done. Now we can pass that then to the solver, and then go, right? Yeah, that looks good. Okay, I was at the Boolean vector. Let's call it the bool vector. Oh, that's a vector that can only store booleans, but it's derived from vector. Maybe I can even define it in here. No, let's not do that. Just define it here. So we have a bool vector, which is derived from vector, but might have a slightly different interface and stuff. So a bool vector stores one boolean No, that stores either a true or false value per square. I'll call it grid here as well then, per grid square. Or shall we just leave grid away and say a square is a square is a square, and everyone knows what a square is, like this, square in my field. Okay, these booleans are stored in as variables of bits, obviously, having only the value 1, true or 0. AKA only the least significant bit of bits is used. The rest is 0. Okay, and let's begin with creating a grid and then displaying the grid. That should show me the bool vector of the mine, so then we can see the grid and where the mines are, right? Now, printing a grid means that we need a friend operator less than, standard stream reference operator, the same thing. OS comma grid, const reference grid. Always very lazy, just calling grid dot print on OS there, return OS, as I always do. And then we have to define, let's put that in front of it, that print on, which takes the output stream, I think that's const. And we have to define this. Well, right now I'm going to put everything in one file. Well, what am I? Yes? Well, why not for now? So for now I'm just going to do write mines to the out stream. Very lazy, but okay. That in turn means that we have the same thing here, of course. Zip. Print on, or print a bool vector, so we have to implement this still. And this just passes it on to the print on. Bool vector. Right, so now how to print a bool vector. Hey Emre, yeah, this is quite followable because I just started. It's like completely from scratch. So this should be followable. I think it's quite interesting. Also, so stick around. I have to start with the most boring stuff, unfortunately. The most boring stuff is writing these print things. And then it gets more interesting. So now, of course, I could just call the print on of the vector. If I was really lazy, you could say, well, base class print on, thank you very much, like that. And then we would print it the same as the vector. And since the vector has only the value 0 and 1, we would get the value 0 and 1. And for now, maybe that is also sufficient. Yeah, so we just pass it on to vector. And the vector is a vector template. Let me implement a vector template. I'm gonna put it in a different header. That one's quite big, I think. And then we have everything. I don't have a default constructor of this thing yet. So far, just using the default constructor of the base class. It should work. Yeah, I have to define this one. Maybe it will be easier to use different files for every class. I totally see it coming. Sooner or later, I want to use my own utilities and stuff. Yeah, definitely. And maybe even debug output. It's just, it sucks, but that means that I have to create a Git. So I'm immediately going to make this whole thing a real project based on CMake and Git. And that takes 15 minutes to set up or something like that. So it kind of sucks, but okay. I'm sitting in C++, so maybe I should switch to projects. I already did something, by the way, along the lines what I'm planning to do, using a bitboard that I wrote for chess. So that's really 8x8 only. On one box. So that's funny, isn't it? So you see something that works already. We're going to head in that direction. Mario, no, I'm postponing it. I'm so scared of it. I'm starting to do other stuff just so I don't have to work on that. It's like if I'm walking away of it, but soon I'll have to face it again. I'm sure. I can't continue to come up with projects that are easy and that I can do it. Well, easy. So the last 2 days that I was streaming was about this ransomware decryption. Well, that was finalized, as in it was impossible. The conclusion was that, well, there was a double encryption going on. So the ransomware had encrypted files that they needed that were stored in a container. And then after that, the whole container, which was a file of 1 terabyte, was also encrypted. And then they pulled out the wall plug from the computer. They just turned it off before the public key that is needed to decrypt it was written to disk. So they lost everything. But at least now they know. So they don't have to keep pouring money and time into trying to recover something that is absolutely irrecoverable. Yeah, and now I'm doing something else. But the idea is that I only work on this for 1 or 2 days again, and then I should go back to Linux viewer, I guess. Let's make a new thing. Minesweeper is available. Description. Minesweeper solver sandbox. Create. Yeah, now we have to check it out. Going to check out the HTTP and then maybe automatically convert it to something else. So we do git. Wait, this is supposed to be my repository. Move Minesweeper to Minesweeper.original git checkout clone Minesweeper stuff. Oh, I have yep, totally empty directory. So let's just copy everything from minesweeper.original, which is a single file, I think, to Minesweeper, not empty anymore. Remove -rf. Now we have a git and my solver still. Okay, now I want to have my stuff, which means that go to my repository, and I'm pretty sure I need CWDM here first, which says adding to a project. That would be that command. And then copy autogen, and then run autogen. And then, well, that's good enough. Git add autogen. And then I need to have also CWS. Which also describes somewhere, I hope. That doesn't describe anything. What the hell is that? Let's just go to utils. Maybe utils is describing this. Adding. Should already be set up using CWM4. We just did that. Git submodule add utils. Check out submodules. Okay, so this one. Or the other one I already have. The easy way to set up libcwd is by using gitash. For that to happen, create a directory. So make dir -p vi slash libcwd make with the contents, copy, paste. And then add the variable key touch root to your environment. Well, I have that already, of course. What? What? No. No way. Of course I have said that already. Is that because I'm not inside projects? That might be the reason. Let's move this to projects because this is not working for me. ls/tick projects. Just make sure there's no Minesweeper here. Okay, lm, nope. Move Minesweeper to projects. cd projects ls here. Environment changed. I'll bet now it's set. Yes. So you just have to be inside the directory project for my environment to make sense. cd Minesweeper and again. So now we have this set. Add the following lines to CMake list in the root project. Yeah, I know it is always more difficult, right? I need to write a whole CMake thing, so maybe I should just go to a test suite thing that I have. Utils should work. There, test suite. That already has CMake lists. And we copy that. Well, basically everything. Everything except microbranch. I don't need that one. The rest is what I need. CMake lists.text. Is that the word? Okay, no microbranch, and of course this is not called utils. So let's call it what it is. Minesweeper. And that's the same thing, same description I just added for Minesweeper, which I already forgot again, of course. So let's go. Oh, the projects, depositories. Man, why is this so slow? Minesweeper solver sandbox. Okay. So now we have some random version. I'm not convinced that this is the right version actually, because it's just very old. One of the more recent things that I wrote is the Gravis, right? Let's look what I did there. Um, 14 to 26. No, okay, we'll just make it 26 then. I don't know about 14. Minesweeper languages, we work C++ 20 still. And then this should get me libc WDR. So now I have my debugging library, libc WD. And then this like, how do you call that? I can't think of the word. What's the word? Template? No, boilerplate. Ah, I remember this. Good. Boilerplate stuff. And then we have a source directory. Make the source. Move solver to source. So now I have debugging stuff and CMake and utils. That's pretty good. Well, at least I checked it out. Okay, let's just go to source and pretend my nose is bleeding. See, make a list.txt. Something gotta go here. Let's steal again from an old project. I have a source here. And this one is okay, so we need to start with include that, and then can add an executable. And well, so as long as I have only one executable, that would work. Let's call this solver. And that one was called solver. Good. I think that should work. Okay, we added everything. And now there is a lot wrong, but the auto-gen here is very intelligent, so I just run it. Oh my god, I did it again. This is so annoying. Don't even have a branch at all? You gotta be kidding me. Huh? You don't have anything. Yeah, I didn't add it. No, the problem is, and I keep forgetting that every time I make a new one, they put stuff in branch main, whatever that is. Which is not what my tools work with, even. So I should have fixed that before. I didn't commit anything yet, right? So it's a completely empty branch. So I guess we can still recover quite easily. Going to the Minesweeper thing, and then actions. No, it's not actions. Secure settings, I think. Pretty sure it was settings. No, also not. It's ridiculous. Huh? I think it didn't do anything yet because I didn't add any file. So let's try to make master from here. Get remote -v. I do have remote, but I can obviously not push to that. Painful. Well, I can push it to it if I type my password, but it's annoying. We need that. So get remote rename origin to GitHub. Git help remote set URL, name new URL. get URL, was it like this? Name, new URL, or not, unknown option set URL, oops, here, no, what, git help, mode, it's not, okay, never mind. Get remote -v. Now it looks like I can push to it. So now we're going to do this. Git push -u. GitHub master. But I didn't commit anything yet. Okay, git add git submodules. That's another one. Git add git commit. First commit, git push. Oh, what? Master does not match any. That's what I mean. We are in main. Let me just push it. And I rename the branch. This is more work, but at least now we are here. Now I should see something under settings, I think. Yeah, now you can see it. To master. Really every time this problem. Maybe I should add it to autogen.sh that it detects that the master is main and then automatically renames everything. That would be nice because I'm getting very tired of that. The default branch name has been renamed. If you have a local clone, you can update it by running the following commands. GitHub move, I guess, branch main master fetch origin branch. What? Okay, let's do something that looks like it. Git fetch GitHub git branch. Oops. Get remote and again. GitHub. Yeah, that looks better. Yeah, finally we renamed it. Goodbye. So now I have now we can run autogen.sh finally. See, it fixes a lot of stuff, and I just should add that it also fixes this branch equals mains thing automatically. So we run it again, everything's green. Yep. Now, which configure? Hopefully the default configure should work. This is just going to check if that is set. And it should be set, but I don't know to what. It's not set. I should set it. So we create an environment for Minesweeper. in which I said that. I better copy that as well, I suppose. Oops. Oh yeah, that's a lot of stuff. Environment. PP flags, clang, and I might as well copy everything again. Yeah. I need to set the top project, which in this case is projects Minesweeper. Then I need an inf.compiler to set a compiler. The repo base is top projects Minesweeper. That doesn't change, that's same, and here we set some stuff, why not? And then here I have let's do debug, and that we need, and that, and everything. And these, I guess, paste. This searches the repo base for .h, or, well, I'm not going to use that, or that, just that. And PRS just searches in source for the same thing. What is this? In Graphis? Nah, no. It's confusing. I don't know. Why wouldn't I be looking for headers? Pose of, well, everything's mostly the same. Okay. And with compiler, yeah, need to copy that as well. Which one's recent enough? None of them looks very recent. Oh, this one, of course. Just use GCC. Okay, why not? So now I can run configure. And then make. And then it says vector template. We don't have it. Okay, I can finally continue with the project, because now I set up my build environment. So we need that thing, VR, Pragma once, class, okay, this is a template, calls, rows, bits. Vector template like that. Totally empty. Include IO stream. And actually I always have to include sys.h, which it will get from CWDS. No, let's also include debug. Now I'm added anyway. Which means you have to debug. How does that work? Debug, namespace debug. Init. DC notice entering main. Just to see that the debugging works. Print on is not a member of vector, aka vector template. Vector template needs a print on. Public void print on standard stream reference is const. Yeah, includes, well, I'm gonna do IO stream, I think, because I have to implement it anyway here. No, it compiles, but we have an undefined reference to grid. So let's make a separate header for. That should be in source. Why am I having this here? Well, source. Move that to source. Say a source. So I'm going to make a grid.h and just move the see, everything is going to be depending on vector. If I only define that here, that's highly annoying. I think the solution is that we have to include vector.h, which then contains these 3 lines as well, and that. So let's make that first. Instead, I want to have a vector.h and copy that into it. That then includes vector implementation template.h, and then we define that, but now it's in header, so now these things must be static. So the const expressions. Yep. Now let's just move top down, so bool vector is the next one. delete, next, P. This is a header, so I should have used the pragma once in front of it first. Yeah, I need a vector.h here. We need IO stream, but it's of course already in. Should I do that again? It's kind of silly. I mean, vector already includes it, so let's just believe it. Believe we already have it. Also, now I have my utils. Theoretically, I don't even need to define this anymore. I already have that. But okay, I'll leave it in. If I would delete this, then my utility stuff is already automatically going to assume this and call print on. With a little bit more, but then I make it a real project, so let's just leave it like this for now. Vector.h. Forgot pragma once here. And then we're going to do the next one. The next one being a grid, finally. Grid. Yep. Next. P. Pragma once. And this one then needs include Boolean Vector.h and IO stream again, but that's we believe that, right? No, solver. Let's leave solver in here for now. Now, of course, the solver only uses Boolean Vector, so we might as well just include Boolean Vector, and which then includes all the other headers. So this is good enough. We didn't do that. Boolean Vectors also including grid? I don't think so. Let's include grid. It's more the other way around. Grid includes Boolean Vector. Yeah, that's much better. That worked apparently, but I still did not define the default constructor of grid. So I need a grid.cxx, which then of course, well, I always need this for some reason, don't ask. And then we need include grid.h, obviously, and then we need to implement grid dout to dc. Now let's say entering, see notice entering grid. So we can follow in the debug output when this constructor is being called. We need debug.h for that. Now still, because CMake now also needs grid.cxx. Can't find grids. Okay, let's change it into grid. And it links. Okay, we're done. Yay. Well, that's a start. So hopefully now it becomes a little bit more interesting. By the way, it did put the executable in let's do a less repo base object dir, I think, source or not. Oh, I said object dir. There it is. Let's make an alias for that in my Minesweeper environment, because I'm otherwise too lazy. So we have an alias here. Solver is solver. Source solver. Yo, the debug output works. So it says entering main and entering grid. I want to know where my extra new line comes from though. But yeah, looks good. I guess this is the extra new line here, because we are printing grid and that just doesn't print anything, but we do still print the new line. Let's begin with implementing the printing. Well, I think only Vector needs it. Vector template needs it. Yep, so that would be this function. Doesn't do anything yet. Well, that ain't easy. Okay, so how is vector template going to work? Well, we have probably public. Let's make an ASCII art thing here. So we have columns. That's vertically thing. So call, let's say column 0, and then 1, and then 2, and then 3, and then that's enough. And then we have rows. Oh, we start at 0, 1, 2. It's also enough. And then we have 3 bits here. 1, 2, 3 bits. And so on. Zip. If calls equals 4 and rows equals 3, it's actually not true. Let's get another one here. I want to subtract 2 from it. If calls equals 2 and rows equals 2, you see now they are equal again, so that's confusing. Let's add another one. If calls equals 3 and row equals 1, then the actual, maybe it's just confusing. Let me think. Nah, let's keep it like this. And the actual grid is calls +2 cross rows +2, aka 5x4. I'm still not sure if we should put the calls first and then the rows, but yeah, as long as we are consistent, I guess. Okay, well, I guess it makes sense to store A in the least significant bit. Yeah, how shall you store this? Okay, let's define a few variables. Instead of const expression. Let's call these different. C and R. And then bits is bits. I'll call this C+2. And rows is R plus 2. It doesn't really make sense to give a name to the bits within one thing. It's more like this is 3 bits, but to be considered as an integer. Yeah, let me think. It is necessary sometimes to talk about bits inside. How shall I call those things? The 3-bit values. Use the name of that as well. Could call them value, I guess. 3-bit value. This grid of five columns, x 4 rows, contains 20 values, 20 3-bit values. The values are stored such that bit shift to the bit left shift, right? Yeah, a bit, and now it's called a bit shift. A bit shift to the left. Makes values move from left to right and top to bottom. A larger column and row values. How do you call that? It's like the major and minor thing. So the row is the minor. The column is the minor. I'm not sure I want to. I mean, if I write it like this, normally C is the least significant value. If this is a, yeah, definitely. See, that's the problem here. If normally, so let's say ABC is an integer, written in binary, then C is usually the least significant bit, and then 1, 2, and 4 values. But I want left shift to increase it, so if I want to keep that like the way I wrote it, I have to put a higher column to the left of that one. So I have to inverse it and put 0, 0 in this corner. Otherwise it's confusing. But I want to print it like this in the end. Nevertheless, let's begin like this. "64 bits, so that's a 3, 2, 1, 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's the 5. The 40, 30, 20, 10, and the beginning. Oh, really? 16th? Yeah, of course. No, not. Phew. Narrow escape there. 4, 3, 2, 1, 0. Most significant bit. Least significant bit. Yeah, check. So if we shift this to the left, like I said here, bit shift to the left, that's that way, then the ABC gets on the place of the DEF, which means we shifted left one column. So I can do this like this. Value sort of such that if a bit shifted to the left makes the values moved from right to left and bottom to top. In the above picture, aka a larger column and row values. Yep. So the question now is then, how many uint64 types do I need? Total bits, calls times rows times bits. Yeah. That means a round up of total bits divided by 64, which means plus 63 and then divided by 64. Right, so if we have 1 bit or all the way up till 64, then we get a 1 here. And we have 65 bits, 65 plus 63 is 2 times 64, so then this becomes 2. And then we're going to have my private array, static array of uint64 type, n data. Yeah, I think that works. But we're going to treat this array as a bit set, and I already wrote a bit set, so I might as well use bit set. Utils bit set, which doesn't get a color for some reason. Why do I not have a color? bitset s utils is in my s. Oh, I never run C tags. Bitset. So now we can jump to bitset, and my bitset bitset POD. Oh, my bitset only allows a single integer. So then we can never go larger than 64 bits. That's maybe not ideal. Yeah, but I hardly want to rewrite everything that I wrote here. Maybe I should use standard bitset. I'm not sure if that stores stuff though per 64 bits. I guess it should. I like keep one of the things that one of the reason I want to use this is because it has these things. And count, and it's another one. Yeah, this one. Next bit, and previous bit. So you can jump with a single assembly instruction to the next or the previous set bit. It's just, well, I don't know, I wrote it and it's fast. So I like to reuse it. But in this case, it's not suitable because, yeah, we're preparing for something with multiple uint 64 stuff things, I guess. So let's just leave it like that. Let me see. Mirin Kern, are you still there? Oh, it's still there. See him in the. So that doesn't work. Is that not an M? Well, anyway, the resolution is that no, we could not decrypt it because the data was just corrupted. There was nothing to recover. So they really lost everything. I mean, even paying doesn't help. Well, they just basically they pulled the plug from the PC while it was still running, and that's what caused that it is now unrecoverable. Okay. Print on. Well, we want to print, I think, a single row. I want to be able to print a single row. Let's begin with that. Print row. But from your TV. Well, okay, Mr. David. What is this? Yeah, I want to print row, but I'm not going to print column 0, or shall I print column 0? We have to keep tabs on it a little bit, right? What happens to the other stuff. Let's print everything for now anyway. Let's print everything. So I need a for loop that runs for from column 0, call less than calls, plus call, because I want to print it column 0 first, so this, yeah, well, the inverse of this. And then we print a single row. That's bullshit. This must be row then. Start row 0, and then we print a row on OS. And the normal print is then that we write a new line after that. So we print all of them, one row at a time, but still. Looks good. Okay, 2yy. And now we implement print row on. So boring, this stuff. Printing. For int call is 0 to call less than calls, plus call. And then we want to print something. I'm going to assume that my bits are representable as a single digit. Sort of dubious, but let's begin with that. So I'm going to need a value at call row. Here's my row. And then that's probably like between 0 and 9 or something like that. So that's just one digit. And you can separate it with another space. Or maybe really separate it, like separator. And then the first time we have a character cons pointer sep, which is empty. And then here we have it. Sep becomes a single space. So we don't have a leading or a trailing space. Okay, yeah, how to extract a value. So let's return an int. It's pretty slow, but well, it's just printing. Yeah, it's not that easy. I might need to read two values. I mean, it's slow anyway, so maybe I should just do it bit by bit. Just, I mean, it's slow anyway, right? Let me do just bit by bit. So bit is 0, bit less than bits, plus plus bit. Or maybe rather use the bit. We start at a bit offset for the first bit of the value. So let's call this offset and offset plus bits, and then offset equals I mean, if col and row are 0, then it must be 0. And if col is 1 larger, then it must be bits larger. And if a row is 1 larger, then it must be row calls, right? Row times calls. So if col and row are 0, then offset is 0, which sounds really nice. If col increases by 1, then we go to the next bit, and if col increases, then we skip that many calls, and yeah, it's just correct. I mean, what else can it do? So now bit runs over all the bits of the value that we have, and I have to test each bit. Then, so we do if test, well, let's say test bit, bit, then the result is incremented with the value bit. That the corresponding value bit, and then the end we do return result, and int is a result that starts at 0. A value bit obviously starts at 1. That's the first bit that we test, and then yeah, well, I cannot add that here. I think value bit shifted the 1 every time. Okay, test bit sounds like weird. Let's just do test. I think that is correct. So now I have to implement the test. Change a Boolean. Put that in here as well. Okay, so that means that the array index is equal to bit divided by 64, because that's just the index of the bit. Yeah. No, and then the bit index inside that word is equal to bit minus n times 64. To get a mask, which is n shifted left by b. And then we return data underscore n and m. For example, if bit is 0, then this is 0. So 0 minus 0 times 64 is 0. To b is 0. To m is 1. So we test the least significant word, and we end it with 1. So we test the least significant bit. If bit is 1 larger, then n stays 0. But this becomes 1 larger, so we end it with 2. And so on until b equals 63. Then we test the last one. B is 63 means that bit is 63, which means that n is still 0. And if then bit goes to 64, then n becomes 1. 64 minus 1 minus 64 is 0. So then we test again with 1 against the next data. So it's totally working. And then everything works. No, yeah. I think it's time to compile again. Could have told it that it is an int. Why am I doing this? It's so weird. Everything is an int until it isn't. Int is not declared. How annoying. Where's that defined? Is that not C standard int? What is this? Data is an incomplete type. I did not include array. Tuple. Guess I forgot to include array. Yeah, totally forgot that. That worked. Solver. And there we are. We have a grid. But now we have values all the way up till 15, I guess. If we run it again. 15. I see a 15 here. So these are my 4 bits. And therefore they go up to 15. And that should never happen, but it happened. How about an assert? So we test those bits, and then we get a value, and then before I return the value, I'm already printing it here. Maybe I should accept it, but not because I assume here that it's a single character. So I'm going to get a v is a value. And then before I print that, we assert that 0 less than or equal v. V is less than 10. And for assert I need debug, so let's include that as well. Now we crash. Good, because, well, we have random values. Random values is yeah, asking for trouble, because then we have values larger than 9. So I need to initialize my grid better. At the moment we don't initialize anything at all. So what I want is that this array is being initialized. Yeah, let's just initialize it with all zeros, I guess. It's in vector template anyway. So we make a default constructor which can implement right here. And just fill everything with zeros. Now this looks like it only initializes the first element, but the rest is also going to be zeroed. I think that should work. In fact, maybe I should not even have to pass a single zero. Anyway, we only have one 64-bit thing, so the array is just one big. So maybe we should test and see. This is 7 by 1, 2, 3, 4, 5, 6, 7, 8. 7 by 8. And the inner thing is 5 by 6, right? So we have 5 columns and 6 rows, and then a square of zeros around it. Nope. Yep, 5 columns, 6 rows, and 4 bits. So now let's test if we still get something that makes sense if I just add 10 here. 15 by 16. Yeah, that should work. Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 2 more for left and right. And this one is, well, we skip the one at the top and the bottom. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep. So I'm totally happy that that worked. Let's make this one 6 again. Six rows. Yep. Not really a test, of course, because, well, filled everything with zeros. I am going to need a auto constructor, really, one that fills everything with a given value. Maybe I should not do this. Just make it a class. Public. I want to have a constructor that literally fills every value, yeah, that's what I called it, with the same value. So every element with the same value, let's put it that way. So, right. You can only do that, I guess, if you have access to it. I could make this protected, so you can write directly into it. But the whole bits thing is a bit complicated, right? I mean, especially because if bits is not power of 2, then it just doesn't fit exactly in 64 bytes. So then one of the words is just overlapping the border between two 64-bit integers. So it's far from trivial, really. I'm thinking, and in the end I need to implement as well an add and a subtract. So that might give me a 64-bit overflow. That's not nice. Maybe I should restrict the number of bits to a power of 2. Or we should restrict the number of words in a single word. Sorry, the number of values in a single word. Let's call this a word. Such that we just don't use the full 64 bits. Just in order to never overlap. In that case, the add and the subtract is way easier to implement. I think I'm going to go for that. Either way, we need to write an interface that hides that shit. Sorry for the bad word. From the derived class, I think. So this now is no longer correct. I need to know the number of values in one word. We need to know the number of values that fit in one word. So bits is always less than 64. It's going to be like way smaller, so not even adding a static assert. What? Why am I not adding a static assert? Just do it, man. Static assert. Bits 0 less than or equal bits. Could make it an unsigned, but no, I hate unsigns. And bits is less than or equal 64. Larger than 0 would be nice as well, I think. Well, bits is out of range. Could add dumb stuff as well for C and R, but well. Let them burn. You know, if anyone is ever going to use this source code and they do something wrong with C and R, then that's them. Values per word. Okay, so how many values per word do I have? Well, that would be the rounded down value of 64 divided by bits. No, it's not. I have to round it up. And this is the wrong way around. Bits plus... no. It is 64 divided by something. Oh, it's rounded down. It was actually correct. 64 divided by bits, yes. So all the way up till 64, we get then 1. And if we divide it by, say, 33, we still get 1. But if we divide it by 32, we get 2, because now it's only 2 fits. Then if we have just 1 bit, we get 64. In the case of what I just tried, 3 bits, and we would get 1 more than 21. So I'm totally happy with that. Yeah, this is correct. But oh, yeah, well, that's not really a shift anymore then, right? Now we can do the arithmetic, adding stuff and subtracting stuff in parallel, I mean. As long as we don't have overflows, of course, or underflows. But. What about a shift? That could still overflow. That is difficult. Okay, I think it's just too difficult. Let's not do this at all then. Bits must be a power of 2. Otherwise I make it myself way too difficult. I don't want to do that. So we want to have bits must be a power of 2. What utils is power of 2 bits. And then I have to include the header of that. It's a magical formula. It's power of 2. Well, and then this example becomes a bullshit. Now we have to make it if bits is 4. And this becomes 20 times 4 is 80. And then what becomes before the X? P, Q, R, S, T, U, V. W. Right. I think power of 2 is going to return false if you give 0 or not. N must be larger than 0. Yeah. So we have that one. But bits must also be less than or equal 64. That wasn't used, except here. So now, well, that still works then now. Yeah, and I can also speed up this one. It's no longer necessary to do it 1 bit at a time. Oh, that is probably not working if bits is 64. Or is it? Actually it is, but it's going to give me a warning then. I don't like UL. Go to int 64 type. So since bits is a constant, it's going if bits is equals 64, then it's going to give me a warning that this is an overflow. I think that gives me 0, and then -1 is all ones, so that's exactly what I wanted. But there must be a way to do it without getting a warning. I think the trick is to shift it the other way. So you just begin with all ones, and then you shift it the other way. Call me lazy, because right now bits is going to be small anyway, right? Now what the heck? I just have to do this. I can't help it. So take the inverse of that. You have all ones. Do not subtract 1. We shift back. So in the case of 64, you don't want to shift back anything. Does this work? Bits is now 0, we shifted 64, and I should not complain about that. And now we get 0. What did I say? Yeah, if bits is 0, we get 0. But if bits is never 0, it's larger than 0. We shifted most 63, and now we just get a 1. Totally perfect. Why is that thing around it? Parentheses. Now what? Okay, I'm going to rewrite the get value anyway, because I also need the opposite, not to read value, but the write value. We might learn from this. So I'm not so much interested anymore in testing a single bit, because we're going to rewrite value. Yeah, I should convert column row to indexes. That's definitely more useful. Maybe I should already have done that before calling value. So yeah, I want to run over when we have a row, we have to run over the columns, but I can convert that to an index. So let's say I is index col, comma row, and then value just takes an index. So let's implement index. Well, that then is yeah. It is index. It's an element index, so it's simply something plus col plus cols times row. Yeah, let's implement. Let's inline that one. Testing a single bit is really silly. Let's not do that and then get a value at index. Okay, just forget it. Begin anew. We need to calculate the array index and the shift. So in the end we return data array index shift, and then end that with the mask. Const type mask, where the mask is value mask actually. This is just a modulo thing. Yeah, it's just index divided by number of. It's called the value index. And my bit is a power of 2, so values per word is a power of 2. And it is a const expression, so if you divide by values per word, then the compiler is going to convert that to a shift. So that's like one clock cycle, even though it's a division. And then this one, is, I would say that, right? And it's just also going to be a bitwise-AND or something like that. Because this is a const expression, power of 2 const expression, and then, yeah. But is it correct? It's not entirely correct, I think. Let's see. So if value index is 0, then array index is 0. That's logical. And that stays 0 until we get to the value that it doesn't fit in that one word anymore. Or that looks very good. And the shift should start at 0 as well. And then increment until this one is incremented, and then that one goes back to 0. But now the shift runs up till values per word -1. So we have to multiply that with bits to get the actual bit shift. Let's call it bit shift. Okay, I'm gonna call this one get value. And then we have a set value. Yeah, now we probably have to calculate these two as well. Seems super logical. And now we have to do the reverse here. Should like something like the value mask, and call it value mask is a bit vague. This is always least significant bits in one word. Yeah, I have to do something. Let's call this one mask in, lack of a better word. It's going to be my value mask shifted that way with bit shift. And then the array must be cleared with that value. And then it must be ORed with the actual value. Shifted value. Where, well, shifted value is just value shifted. Yeah, let's do value bit shift. And then I might as well not use that. I put it like that. So we clear the bits of that value at that position. And now we override it with the actual value. Yeah, looks good to me. Do this compiles. Not compile. What? How on earth? No declaration matches. Set value int. Oh, it didn't declare it. Set value int. Thought I added it. Set value, yeah. Int. Oh, I added a const. No, what? No declaration matches set value int. Still, gotta be kidding me. Yep. Void. Error uses deleted function Boolean Vector. Implicitly deleted before because the default definition will be ill-formed. Because vector no longer has a default constructor. Did I not implement it yet? I did not implement this one yet. So, but default constructor is just going to fill it with all zeros, right? Is that a bit too slow? It's probably going to be slow. Let's make a separate one. Vector. I'll have to implement both, I think. So this is going to be an undefined reference like this. And even reference to vector and not vector int. didn't get to that yet. Well, yeah, because I don't even have a vector.cxx. Include sys.h, include vector.h. Oops, nothing. No. Okay. Well, vector, and another one for int value, I think. Let me find reference CICM vector.cxx. That worked. You have to implement them. So the vector now is kind of annoying though. Vector template. Did my vector template have a default? Oh, okay, that one has a default constructor. So that's the only thing I want to do here is just have it. Hell, default. So just exist and then use the default constructor of the vector template. This one, however, yeah, can use the default constructor of the template thing, which is done filling it with zeros, which is kind of a waste because now we're going to override it again. Nevertheless, so now we run over all columns. Yeah, that's over all indexes, of course. Value index is 0 till less than max index plus I. Set value. Yeah, set every value to the value. Except we don't have a max int, but okay. We do have a value, a set value. Yeah, which is public. Yay. So we just need to add a public max index. Static const expression into max index is well, actually it's just the number of elements, so that's just cols times rows. It's kind of silly to have a max index, especially for that. I don't want it. No matching function for call to, yeah, of course. Value I, comma value. And that worked. And I'm not calling it yet, I think. I'm still having just a grid. So my grid vector of mines. Yeah. My bool vector is not initialized, but what if I do mines? And for the heck of it, I'm going to fill everything with one value, namely 5. But that's a bool vector, not a vector, so I have to make sure that also this one has it. So we have a bool vector. Default. Well, that's nonsense. I cannot have a bool vector that takes 5 as a value. Test this separately. No, I'm not going to do that. Let's just create a vector and print that. It just seems a little bit easier to vector, well, grid, whatever, 5. Yeah, that's what I meant. And nothing works anymore. Scroll. Operator less than does not work on a vector. Since when does my vector not have that? Okay. vi vector.h. Yeah, I don't have a print on here, but it's just a vector template, and that one has a print on. Can I not? No, just add it. Or shall I not add it? Oh, well, we have a few 5s, but not looking like I wanted it to look. What went wrong here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We'll never know, I think, unless I run it in a debugger. Sorry, command run. What? No should follow directory. Word. That is. And these are 64-bit integers, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, okay. Yeah, no, whatever. Well, let's have a look at vector.h, because of course I forgot again, of course, what we said. Calls is 15, rows is 6, right. 4, 64 bits. Okay, so we need 6 times 15 times 4. We need 360. That's 5.6. So we need 64 bits. Yeah, that's correct. What did I say? 6? Yeah, and we have 9. It's not correct at all. Oh, I have to add 2. I'm an idiot. 17 times 8 times 4. 544 divided by 64 is 8.5. Okay, rounded up is 9. And they're all 0. That is then printable, I hope. Yep. So that would be 17 times 8, 136. Yep. And then I is going to run over all those values to do next. Print I. Print value. If I'm going to do 136 times call set value, then something's wrong when the half of them end up with 0. So set value is not working, apparently. Yep, we don't know how big that is. Very annoying. Yeah, well. It's definitely going to give me 0. Bit shift, also 0. Value mask. Yeah, how can I work with this stupid debugger? That's not debuggable. Anyway, next. Print data. Next. Print data. I'm totally happy with that 5. Next, next. Step. Next. This should be 0. This should be 4. Next, data should be unchanged. Next, data should be 55. Yep, that worked for me. Well, it's going to do 8 of them anyway. So let's just continue. Step. That's the third one. The fourth one. Fifth. Oops. I think this was 6 and that was 7. So now we're going to do 8, which means that at the moment I have 7 5s. Yep, and then we do next, and now I have 8 5s. No, because I have to do one more next. Oops, and of course I ruined it. But we have 8 5s. Step. So now I equals 8, and value is still 5. Yeah. Step. I guess now we must go to the next array index. So we do next. I expect this to be 1. Oops. Oh, right. Yeah, but yeah, it's actually correct. That one is only 32. Next, print data. One, 2, 3, 4, 5, 6, 7, 8. Oh, what went wrong? Oh, that went wrong. 101. Quit, yes, VI. Value. To static cast that to an in 64 type. Value mask is already 64-bit or not? It's int. Let's make that on that as well. Seems safe. And we have all fives. Is there 136 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 2, 3, 4, 5, 6, 7, 8. It's still the same, of course. Yep. No, that seems to work then. Okay, now I'm not happy with, well, maybe I'm happy, I don't know. Twins is back to grid. All zeros. I should go eat, and I should fill this grid with a minefield. Default constructor of grid. Run over call equals 0, call less than calls, plus call. Rows equals row is 0. Both less than rows, plus row. Int value index dex. Actually, I want to run from 1 till plus -1. No mines in the, only mines in the center. Wait, what am I doing? Create. I think this is too slow. Oh, it's too slow. No, we're not going to do this. Grid has grid. It is mines. What about I just fill I fill the whole array with a random number, just to begin with. So we do we use say mines, and then I say randomize. Okay, but it's a Boolean, so I need it to be ended with the, well, Boolean mask, obviously. Yeah. So the Boolean mask, let's define a Boolean mask as part of a vector. Mines is also a vector. Well, it's a Boolean vector. Maybe we should define it. Boolean vector. Boolean mask. Yeah, 2 new functions to make. Randomize. Let's start with randomize. Randomize should be part of base class, the most base class thing that we have. Now this is a pretty weird thing. Can't really do that as public, I think. So this is just bullshit. That's what it is. Protected. But derived classes can access this, and then it will just randomize this data completely. I just make them up as I go. What do you think? Every time I call randomize, you just want to start over-ish, or no, that would still be slow. So I need an Rn. Rn is my random number generator, so I'm gonna call that the random number. It's actually not that, it's generate. I need to find random number. Let's make that a static. How does the thing work? It's just a normal class. Random number. So I call it S. Because it's static, we have to define it here. Static details. It's part of the thing. So you need to template everywhere. So now it's defined, and then can use there. I need a dist. This could also be static, I guess. I don't think that creating a disk is very slow though. So we might as well do that in the functions itself. Let's see, generate requires an uniform distribution. Some int, okay. Good question. Well, 0 till maximum possible value. Getting lazier. Should have used standard limits, right? Let's do that. Yeah, standard limits, I think. Is it numeric limits? Numerical limits, int 64 type, min, comma, same thing, max. Numerical limits is a header. Or is it just limits? I really don't know. Subcommand fields, limits. Hi Zas, hello Carlo, I noticed that you use underscore instead of memo prefix. I used the M underscore my whole life, hi Zas. Well, not my whole life, but for a very, very, very long time. And then ChatGPT 4 came along. I asked ChatGPT to generate something, and it used not M underscore, it used an underscore at the end. And I liked it, so I switched. I'm not someone who holds on to stuff because I did it. Well, sometimes I do. But in this case, it's just... if it feels better, then yeah, through the drain with everything I did before. I still have a shit load of software where I use M underscore as prefix. Really lots. Lots and lots and lots. Even M, uppercase M underscore. That's what I also used, I think, at some point. But yeah, no. Right now, I think that an underscore at the end is just better. It's shorter and it's less distracting. That's apparently what most people use. There must be a reason for that. I really should make dinner. I'm an idiot. Why am I not making dinner? It's probably just limits. Random number is unknown. Include utils slash random number h. Include make. Error vector randomize is protected. Oh. Well, okay, then I make it public. Oh, protected here. I don't think so. Okay, we'll just make it protected-ish. I'm still busy, Mushroom, I'm still working on printing stuff. So I'm just really totally at the beginning. It's really horrible. Boolean mask. Something is coming here. This is the first time we do something interesting. Like I have to define this, and well, we have to generate the Boolean mask. It's part of Boolean Vector. So I want to create public and static const expression Boolean mask, which is a vector. Create Boolean mask. Yeah, might as well make that a static function then, I guess. To make it a private static function. Let's see if that works. Private. That's a const expression. Vector. Create Boolean mask. I guess it has to be inlined, otherwise the compiler can never run this during compilation. Or can it? Maybe it can. It should be. It should be able to, because it's nonsense. This is really nonsense. No, it's not nonsense. Wait a minute. It's a const expression. I have to initialize it right here. What you want is that the compiler is going to run this function, the compiler, and then comes up with a vector, a complete vector. That's just an image of vector. And then it just hard codes it. And if you make something const expression, then the compiler might actually do that. Or I can make it a const eval, then we know 100% sure that it's doing that. Let me see if this gives errors. Gives already errors. Create Boolean mask was not declared in this scope. That's kind of weird. Boolean vector used a nested name specifier. Yeah, so. Error type const vector. Vector is not literal. No, that's correct. Vector is not literal. Okay, it's I don't know. Let's do it at a runtime. Who cares? So I'm going to make it a static anyway. Don't want it in every bool vector. I'm going to make it a const, but we'll have to do it during runtime. Don't even have to define this here then. Might as well define that in the .cxx. So this thing now goes into boolvector.cxx, which you don't have yet. Boolvector.h. And then here we can initialize it with my generate Boolean. Why is it suddenly called Boolean mask? Oh, it's still, has been for a while. Namespace anonymous. Delete. No. Poo-poo. Okay, this is going to be run just once, yeah, to initialize this static thing here. So it can be slow. And what we need is that, yeah. Let me think. Yeah, just run over everything to begin with, I suppose. Calls. See if this works. No return statement. Okay, we have to return something here, of course. Return a result, but for the rest it worked, right? Vector results. So my default constructor fills everything with a 0. That was this one. It's a default constructor, yeah, totally zeros. So we have all zeros. That already takes care of the border then. So I just want the inner rectangle filled with ones everywhere. So really we just have to run over the inner thing. And then I just said vector, is it not like set value? Dex, call row, comma 1. Now what? Index, it doesn't know what index is. Confused. Oh. We are not a member of. I guess that I have to call this on result. And index is, well, could be a static function of vector. I don't know even if it is on vector or not. What is that? Dictionary ultra hash. There's no vector, no index inside. Index tags. Try that again. Where's my index? Vector template. Yeah, well. Totally static though. Static. Might as well put it there then. It's also public. That should work. Yeah, not really. You cannot make a const. Okay, and then the last thing is that one. A vector, I want to have that operator now. For whatever this is, it's Boolean Vector. I think that might only make sense for a Boolean vector, but on the other hand, let's do it for the whole vector. So we want that operator. Those things usually return a reference to this. Input is another vector. Const reference. Not really. It should be also part of the vector implementation, right? Implementation. Vector template, I mean. So we're going to add this, except it's a TMPL. Put it at the bottom. Well, not that bottom, this bottom. Stupid templates. Everything has to go in the header. Okay. Well, that should be easy. Finally, we are talking. Speedy Gonzalez. That's a template. Other should be anyway. Deduce class type in return. It cannot do that. It wants to know what you mean. Undefined reference to Boolean mask. What is this? Warning no return. Yeah, return this. So now everything looks good except for the undefined reference to Boolean mask. Where did we add that? In Boolean Vector, which is, I'm pretty sure I added that in Boolean Vector.cxx. There it is, Boolean mask, except that I didn't. So this is Boolean Vector. Yeah, it works. Okay, solver. Da 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 da. Okay, this is a random grid, random mines. Everywhere you see a 1, there is a mine. And mysterious reason, there's very coincidental, no mines here, and also no mines here, no mines here. which is exactly 2 wide and 2 here. I think we did something wrong. Yeah, there's a bit too much coincidence there. So these are definitely 0. Sorry, I'm not looking at the chat enough. Cons expression calling when application is built. I thought that's confusing. I answered mushroom here a long time ago. How the project is coming along. Kind of just started, I said. I'm still working on printing stuff. Yeah, cons expression is something that is allowed to be used in a cons expression. Very vague. Which might or might not happen during compile time. Usually it does. But it doesn't have to. You can define a cons expression function, and then if you have a cons expression variable and you initialize that with the cons expression function, then the function should be called by the compiler during compile time. But you're also allowed to call that same function during runtime. Why is it not filling those last two twos? I'm going to stop, I think, unless I have more than 10 viewers. Haha, look, 3 viewers. I'm going to eat dinner, take care of Carlo, and then I'll continue later or maybe tomorrow, I don't know. Probably tomorrow. Tomorrow is better. Because you just have to eat. It's the way it is, says my stomach. Yeah, we both want to know why it's not filling it completely. I guess my mask is wrong. Okay, we just have to do that sort. We just have to do this. Solver. So we can again make a vector called grid and fill it with Boolean Vector Boolean mask. Just to look at the Boolean mask. Quite obviously that's going to be, yeah, that mask. So my Boolean mask is wrong. That is defined here. This could be fixable very quickly. Oh, it's taking the wrong calls. Calls and rows. Yeah. Let's just use vector calls. Vector rows. Yeah. That should do it. I should rename those variables. Let's rename them as well, because it's kind of weird that they are being called like this. Or not? What do you think? Okay, no, I don't know. What do you say? I don't know. It's totally vector here. Ah, what the hell, who cares? It's not a project. It's just a gadget. So now we have the correct mask here. The Boolean mask. That's all the true values that are allowed. And then I'm going to change this one back again to grids. And now of course it looks so okay. Da, 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 da. That's a lot of mines though. A bit too much mines but okay, in the end probably want to test everything, plus it's a bit big anyway. Let's go to the vector.h. Choose that to 5 again. Good. Oopoo. Yeah, all of that was just getting set up. So I guess the next time is going to become way more interesting, because this was just boring setting up stuff. But yeah. Dinner time. I'll be back later.